Everybody, hopefully you're having an awesome day and making this day awesome for the substitute. I want that substitute to say, wow, what a class. Could you be absent tomorrow so that I can sub for you again? I want to have that class every day. That's what they should say about you. Got it? All right. Looking forward to an amazing report from them. Okay, here we go. Now, you should have been given two pink sheets, one that says proportional linear relationship and one that says non-proportional linear relationship. Notice they're both linear, and we'll be looking at some characteristics of those. And we have the biggest test day, mega test day, coming up, the NJSLA. Okay, a couple months away. Now we have to start reviewing so that we can make the mega test day the mega best day. All right, we need to work at it. We gotta review, go over stuff, and really get ready for it so we can feel good about it and ready to crush it. All right, so everybody make sure you have the proportional one first. All right, make sure it says proportional. Make sure it says proportional right there. All right, that's the one we're gonna look at first. All right, and let's look at, we're going to try to find characteristics of proportional relationships. Then we're going to try to apply them, use the characteristics to help us solve other problems. All right, that's the key. All right, just knowing the characteristics is one thing, but using them to help solve other types of problems in different situations, that's where you really can do some work. All right, and crush some tests. All right. So let's look at this first, proportional linear relationship. All right. Now, what is a relationship, first of all? A relationship in math is a comparison of two quantities. What are quantities? They're just countable things you can measure. All right. And if you read in our explanation, the first relationship, it says Milo earns 4 PBIS points every day. More like 4 PBIS points every minute, right? No, every day. All right. So what can we count here? Okay, what are the two things that we can count? We can count points and we can count days. So those are our two quantities. It's just an amount of something, right? An amount of points and an amount of days, and they're related. How are they related? Every day he gets 4 points. Okay, and that's what we call a ratio, all right? Or a rate. So now we want to see characteristics of this relationship, okay, between points and days. We want to look at it, notice things about the explanation. We want to notice things about the table, the equation, and we want to notice things about the graph. If we can find all these characteristics and know them well, we can try to apply them to different situations that help us answer troublesome questions and problems. And solving problems with these characteristics is our goal. All right, so we know it's 4 PBIS points every day. All right, so we call that 4 per day a unit rate, 4 for every 1 of something else, right? So now let's fill out our table. Go ahead and pause and then fill out the table yourself. Okay, pause it. Seriously, don't just wait for me to do it. Pause it, then see what I do and see if you were correct. All right? All right, hopefully you paused. Here we go. The number of days I made X, all right, and the points is Y. That's because the number of points Milo has depends on the number of days that he's at school, right? All right, if he's not here, he doesn't get points. But the day still goes by, he just doesn't get points, right? So points depends on the days that he's here, okay? So at 0 days, he gets 0 points. Then after 1 day, it's 4. After 2 days, it's 8. After 3, 12, 16, 20. Now, what do you notice here? Well, a couple things I notice. I know the points go up by 4 every 1 day. I also notice something important about proportional relationships is when we divide all these values, right? Right? 8 divided by 2, 12 divided by 3, 16 divided by 4, 20 divided by 5, and 4 divided by 1, we keep getting the same value. What do we call that value in proportional relationships? Yeah, we call it the unit rate. There's something fancy we call it. We call it the constant of proportionality. Yes, you must say it in that accent as well. And we know that when we divide our y by our x, right, our y value by our x value, we get that special rate, that constant ratio of 4 to 1, or 4 points per day, right? We saw it up here, 4 points every day. That's called our constant of proportionality. Okay? We also have two important points here. We have this point here, which is the origin, right? Every proportional relationship goes through the origin. And then we have another important point where when x is 1, the y value is our constant of proportionality. We'll see that. You can see all of these pairs, 5 to 20, 4 to 16, right? All these pairs simplify down to that one right there, that special one right here of 4 to 1. Okay? So we're looking for characteristics, and we are seeing those characteristics and then seeing how to use those characteristics to help us solve other problems. All right? That's the key. Now, let's look at the graph. Okay, I gotta zoom in a little bit because it's hard to graph on my small phone here. But we can put 0, 0. All right, we're just taking these points in the table and we're putting them on our graph. So now I'm gonna do 1, 4. I have 1 day and 4 points. Okay, 2 days would be 8 points. 3 days would be 12 points. 4 days would be 16 points. 5 days would be 20. And then I'm predicting 6 would be 24. I'm sure you could make that prediction as well. I'm going to zoom out. I'm going to try to draw the straightest possible line I can draw. It's not perfect, but you get the idea. Okay. Now, this shows another characteristic of proportional relationships. All right, proportional relationships, write this down, always are, what do you notice about that? They are straight lines through the, what's that 0, 0 called again? Through the origin, right? So that's one of our big characteristics of a proportional relationship. All right, well, okay, let's see if we can see some of those other characteristics in this graph. If we zoom in here, okay, we see that it goes through, oh, my line's pretty terrible. We see that it goes through the origin here. Okay, that's one important point. But this other important point right here, check it out. Okay, 1, 4, make sure you're writing it in as we go. All right, that's a special point. On any graph, if you can look at where 1 is on the x and go up to find this point here, and you can see the y value there. Okay, see, 1, 4. Well, that tells you right there, it's 1 day, 4 points. So what's our unit rate there? 4 points per day. Okay, so this is a special point, 1, k. And k represents our constant of proportionality. Constant of, oh, sorry, I didn't say it correctly. Constant of proportionality. All right, gotta sound smart when you say that word. All right, so here's a characteristic of it. Okay, it goes to the origin, we see that, but also that first, if you can find where x is 1, then your y value there is gonna be your constant of proportionality. See, the 4, and what was our rate up here? The one they gave us right from the get-go? 4 points every day. All right. Now, what if you can't find that point? What if you can only find other points? Well, let's look at and see if there's any characteristics between these other points that can help us. All right. Well, this is 2, 8, and this point here is 3, 12. Well, can we get our constant of proportionality there? Of course we can. Okay. This is your x and your y. This is your x and your y. First of all, you can just say, well, that's 8 points in 2 days, 8 points 2 days, and 12 points 3 days. Well, if you find the unit rate, how many points is that per day for each? 4 points per day. Okay, so we can also think of it things start going crazy when I put symbols in here, but remember, we can always find k, or the constant of proportionality, by dividing the y value by the x. So we take our y, which is 8, and divide our x, which is 2, and that gives us that 4 points per day, our unit rate, or our constant of proportionality. All right, can we use this point as well? Well, yes, we can do 12 divided by 3, and that gets us 4 as well. All right, so you see in the table, you can do your y divided by your x, or you can find that first point and notice your constant of proportionality is 4. And you can also see that same thing in the graph with those points, right? Where x is 1 is your constant of proportionality, or you can just divide your y and x value to get your constant of proportionality from other points. Works up here as well, of course. 4 comma 16. 16 divided by 4. 16 divided by 4 is 4. All right, so anytime you have a straight line through the origin, you can just divide the y by the x and get the constant of proportionality. All right, so doing a pretty good job so far. Let's rock and roll over here on the equation. All right, so this is telling you the relationship in a simple format between the points. So this is the total points. All right, that's what x represents after. So that's what y represents, and then x represents the total number of days, right? And then this is the multiplier. All right, this is how we calculate the total points after however many days, right? Well, after 4 days, what do I multiply by to get 16 points? After 5 days, what do I multiply by to get 20? Now, wait a minute. Isn't it just that number we kept getting when we divided? Isn't it just our k, constant of proportionality? All right, so our y equals 4x would be our equation for this relationship, because the total number of points times 4, that's our unit rate. Okay, in this case, it's 4 points per day, right? Okay, our constant of proportionality there. Okay, that's what we put in there, and that's what we multiply the number of days by to get the total points. So if I said, oh, hey, 100 days, how many points would you have? Well, you just simply do 4 times 100, which is 400 points. Okay, so this guy here is always your constant of proportionality. Okay, pause if I get too far ahead of you, rewind, review, okay, listen to it again. All right, so we found a lot of different patterns in these proportional relationships. Now let's compare and contrast it to, get your other sheet out, this non-proportional linear relationship. All right, Milo, this is in the next year, I guess, and they let you keep 10 points. Okay, let's check it out. This is non-proportional. It's still linear. So what does that mean to be linear? Still linear, but it's not proportional. Let's compare and contrast and see if this helps us understand. Okay, so now he has 10 points already, and then he earns 2 points per day. Still a relationship between two quantities. What are quantities? The countable things, right? The things we're measuring. So what are we relating? We're relating the number of days to the number of points. Those are our two quantities. Now, how is this different already? Well, if we look back at the other one, there's only one unit rate. There's no upfront amount. He didn't get to keep any. At 0, he had 0. 0 days, he had 0 points. But here, seems like at 0 days, he already has 10 points. Okay, so we're going to see how this is different, and the differences start quickly. All right, here we go. So at 0 days, up 10. So there's no origin in this case, is there? We're not going through the origin anymore. All right, we're already starting up here at, if we go to the graph, 0 days, right? We go up there, we see 0 days, he's already at 10. All right, so look at that. Where in the other one, at 0 days, he's at 0. So that's a good big difference between proportional and non-proportional. Linear, okay? Not through the origin. Now, what is it going to increase by each day? So there's still that consistent rate of 2 points being added every day. So we have that 2 points being added. So we have 0, 10, but on the first day, he's going to already have 2 added to that. Second day, 2 added to that, 2 added to that, 2 added to that, and 2 added to that. All right, so what patterns do we see that are similar? Okay, one thing I see that's similar is it did go up by 2. It went up by a consistent number, and this went up by 1s, right? So basically it went up by 2 for every 1 we increased there. Here, does it have that same kind of like pattern? Well, it went up by 4, the same number, 4 each time, and 1 each time. Okay, so that's a similarity. They go up by a consistent rate, all right? But what we saw with our proportional relationship is that when we just divide these, right, it comes to the same number. So here, we could divide all those pairs. 4 divided by 1, 8 divided by 2, 12 divided by 3. You always get the constant of proportionality of 4. But here, we no longer get the same number. When we divide y by x, we're getting weird, different numbers. Although they're similar in the fact that they go up by a certain number each time, they don't have a constant of proportionality. They don't both have a constant of proportionality. This one doesn't. Nope, 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 nope. Okay, so that number isn't going to be the same. Okay, so that's a big difference, and it limits the way we can use these non-proportional relationships. Okay, we can't set up proportions to solve them. All right, now there's other things to do, and we'll learn about that in a sec, and you'll learn a lot about it in 8th grade. But right now, we're just seeing how this is different than proportional relationships. Okay, let's look and graph and see some of those differences again. And similarities. There's a couple similarities as well. So it doesn't go through the origin, right? It starts there. And after day 1, it's up at 12. Day 2, it's up at, 14. Day 3, it's up at 16. Okay. Day 4, remember, I'm just looking at my graph here. Day 4, it's up at 18. Day 5, it's up at 20. Can you predict what it's going to be at day 6? See that little ramp there? Now draw a straight line as straight as you can. Okay, it's going to keep going as long as Milo shows up to school. Okay, and we notice that it's straight. Straight line, straight line, straight line, straight line. Okay, they're both straight, but this one does not go through the origin. Another difference it has is that when you find that 0.112, that is no longer your unit rate, right? Remember, the unit rate here is 2. It goes up 2 per day, okay? But this is not your unit rate, whereas notice here it said 4 per day, and look at 1 comma 4, right? So you can't make the same predictions here with this non-proportional relationship. Okay, also, you can't just do y divided by x to get the constant of proportionality. There actually is not a constant of proportionality, okay? Because every time you use these numbers, 2 and 14, if you divide them, you get different numbers. That's not helpful. Okay, so the similarity, it's a straight line. Differences, well, it doesn't go through the origin, and it doesn't have that constant of proportionality that we used in the other one, that we found in the other one. Okay? Now, there's something interesting. Okay? It does still climb at a consistent amount each time, right? So how can we use that? How can we use that? Well, this isn't something that you'll really need to use in 7th grade, but in 8th grade, you'll see this a lot. It's a big focus of 8th grade pre-algebra, okay? Well, the number of points, okay, it actually starts at 10, and then increases by 2 per day. Okay, so you can always calculate the number of points by just starting at 10 and then adding on 2 every however many days. So if there's 4 days, you'd be 4 times 2 is 8. Okay, so it went up by 8 plus the 10 it started by. Okay, so this is a special formula. Okay, now most of the time it's written like this though. You have your unit rate here. Unit rate goes in front of the x, so it goes up by 2 every time, and it started at 10. Okay, that's your, they call this the y-intercept, or no, sorry, not the y-intercept, the slope of 2. And that slope idea comes in here. It's like up 2 over 1, up 2 for every 1. Okay, that's your unit rate. And then this is your starting value or initial value. Okay, so this is just a preview of next year. And they write this formula, y equals mx plus b. This being your slope and this being your y-intercept. Now, you can forget that for now. Just forget it. Don't remember it at all. Please don't use up space that we could use for our stuff this year. All right, stop looking at it, stop remembering it. Okay, here we go. All right, so I just wanted to do that one so you could see the differences. Okay, now you're going to practice with a bunch of proportional relationships, and you want to see if you can use these cool characteristics of proportional relationships to then help you solve other types of problems. All right, I hope you have all of this written beautifully. Okay, and then we'll use this to help us solve these problems as we prepare for the mega test. And we're going to make it the mega best. Let's go.